I'm going to present you some of the work that I've done last year. It's been quite a crazy year and it hasn't really finished yet. This is going to be about farmers' use of weather and forecast information. This was funded by the Bureau of Meteorology through the Royalties for Regions program. And it was done under the leadership of Myrtille here. So I use different colors here because weather and forecast are two different things. When we talk about the weather, it's the almost now real-time information. And you probably all have consulted the radar loops on your phones, but you also have what's called the latest observations, essentially all the temperature, precipitation, etc., that are being recorded. And so that's the Bureau of Meteorology version, BOM, and that's the Department of Agriculture, which presents those in an interactive map format, for instance. There's many others. While the forecasts are predictions, and they also come in a number of formats. You have, the actual forecast that you are very familiar with, 1 day ahead, 7 days ahead. There are barometric maps as well. You got satellite imageries, number of things. There even are a few agricultural forecasts which were especially designed for farmers. The point of that is that when you talk about weather and forecast information, that information is relayed via a lot of different products on a lot of different platforms from various providers, not only the government via the Department of Ag and, DPIRD and the Bureau, but also third parties, which are private. You also have some international companies and international models. So sometimes the data that all of this is based on is the same, sometimes it's different, interpretations may vary, etc. To complicate things, you even have what's called seasonal outlooks. So those are not forecasts, they're actually models for the very long term, a few months ahead. And then you got records. So there are just lots and lots of different things. All I had to become familiar with at the very beginning of this because I had no idea. So this study is part of a larger project about assessing the benefits of Doppler investment in the wheatbelt here. Essentially, only the pulse radar, the serpentine radar, used to have Doppler capacity. So essentially, it's a newer, better radar that collects a lot more information, including wind speed and direction. But with the Royalties for Region program, they installed 3 new radars in Waterloo, Dudlakin, and Newdegate. Before, there was almost no coverage of the wheatbelt. So farmers didn't have access to the loops that you have here when you look on your phone. And to assess the benefits of those radars, I realized that we needed some kind of baseline because if you want to assess the added benefits, well, you need to know what was the situation to start with. So the question was, well, before the radar, how were farmers accessing all that information? What were they accessing? And are there characteristics in the farming population which are impacting that use so that we can do a bit more detailed assessments? Importantly, how that information was impacting farming practices, because that's how you can then access performances impact. I also looked a little bit about opinions. I don't usually look into farmers' opinions. I look at what they do, but there it was actually a good thing to do. So I picked 3 study areas in the wheatbelt: Cunderdin, Pingelly, and Newdegate. And this was all based on semi-structured interviews. I had about 51 respondents that represented 37 farms, and most of the respondents were the main farm manager. So importantly, I tried to minimize the biases in my sample as much as I could. So I knocked on door, random selections. So there was no bias from possible listings, one-on-one interviews, so no peer pressure. And I also had a very high response rate, well, kind of the highest you can get. And so there wasn't any self-selection biases, for instance. So this is as representative as it can get, apart from the fact that there were only 50 respondents. All right, straight to the results. First question was, how often do you access weather and forecast information? Those are open questions. So with the response I had, I defined an index, like an avidity index, and I have to thank Matt here, I think, somewhere, who actually gave me the idea. That index combines the frequency of access, so how often they access weather information, and how many products they access. So that's a 0 to 10. And I compare that avidity for weather and forecast information, so how keen they are, with several variables, including age, and I found no relationship. I looked at farm size, importance of the cropping program on the farm, whether mixed farming had an impact versus only cropping. I looked at the technological levels. That was another index I defined, and I just couldn't find anything. And that's important because there's no information about how farmers use weather and forecast information. It's all based on assumptions. And a common assumption is, well, farmers who are more technologically advanced, surely they use information and communication technologies more. Well, actually, no. They all do. And in case you wonder if I simply didn't detect relationships because my sample was too small, well, actually, there were a lot of other relationships I could find that were quite significant. You all know social sciences, R-square, not adjusted, of 0.5, that's pretty high. So I don't think it was a small sampled thing. I just didn't see any relationship. Next question, I asked farmers, so what do you use when you want to look at the weather? What do you mainly use? What are your main sources of information? And people mentioned about like 20, like in total I had about 20 different products mentioned, and each respondent mentioned 2 to 10, so 5 on average. Here they are. So that's 2 different ways to represent the results. The first one here is simply like the percentage of respondents. So 80% of respondents use the bomb radar, but almost over 40% use the Elders app, for instance. And when you look, so that's like how many respondents use what. But when you look at all the responses, and you just like, do a pie chart in the square format, so that's what you get. The radar is only one of the many products that are used by farmers. And the importance of third parties is massive. So farmers essentially, all the farmers use only at least one BOM product. But overall, BOM products represent 50% of everything, the rest being represented by third parties, such as the Elders app, UWA, Oz Forecast, Windy, lots of those different products. Asking farmers why they were using those products and not others, the first answer was, well, I use this because it's easy to use, and it's in compact format. I don't have the time to research and compile the information myself. And also sometimes I prefer this app or this website because it's more accurate. So those were the main reasons. The other reason was that farmers, like to look at a lot of different things and compare. So that's interesting because they know that all of that information is based on BOM data. But it's clearly presented and interpreted in ways that vary because farmers can find discrepancies. And then there was a small proportion, but not negligible, that actually didn't choose anything. They just picked what was there, or recommendation. So there's a bit of a awareness issues of what's out there. And once again, delivery of the information, so how you deliver that information is important. Farmers tend to prefer compact, concise, well-designed apps. Next question. So all of that before, it was open-ended, so I just asked farmers what came to mind when they were talking about weather and forecast information. But of course, there were particular products we were more interested in the project. In particular, things that had to do with the radar. And so those were yes or no questions. Are you using the radar loop, which is a qualitative output, so how much rain is coming? That's probably what you use as well. But there are also something on the website called rainfields, and the Bureau is very proud of that because that combines the qualitative information of the radar with the quantitative on-the-ground information provided by the automatic weather station. So that actually tells you how much rain you got in the last 1 hour, 6 hours, or 24 hours. So it's actually information really important for farmers. And not even half of them use it. And that's because they actually don't know it's there. Because the button is a little link in the corner of the web page, and people just don't know it's there. And they're interested. Every time I showed them to them, they're like, oh, wonderful. Well, now I know. For the Doppler winds, well, that's a bit understandable because this is a new feature of the radars. But same, people had no idea really what's there. Well, already existed in Perth. Same with MET-I. Is anybody using MET-I here? Nobody? Well, this is the flagship platform of the Bureau of Meteorology. They spend a lot of effort, funding, and energy into developing a all-together web page that integrates everything. And people don't use it much. Here, it's an awareness problem, but it's also because it's too cumbersome. It doesn't load very fast. It's not very intuitive. And so there's a lot of problems that limit the use. And then there is a BOM app. Maybe you're aware of it. Then most of the time, people look at it and then they forget it because Elder is a better option. And there's a series of products like this. I won't go into the detail of everything. An important thing is that the seasonal outlook, so the very, very long time predictions, like 3 months ahead, people don't mention that as a main source of information, but there's still a lot of farmers who still keep an eye on it. Doesn't mean they use it, but they look at it. Something that was very disappointing for DeepEarth was that their decision support tools, their online tools, they have a lot of them are not used very much at all by farmers. The Bureau started to put some YouTube videos to help with extension, but people are not aware of it. And when you talk about extension, like the possibility of people coming to the wheatbelt and talk with farmers, well, they're interested, but in fact, they don't really go. And that's because they're time poor. On the other hand, everybody listens to the weather segment on the radio, on the tractor, because, well, there's no opportunity cost of your time there. So when the government or third parties develop products to transfer that information, they have to be aware of the fact that farmers are time poor. They already spend a lot of time online looking at those products. So whatever is designed, it has to take those things into account. Perhaps podcasts to listen in the tractor. Last question about what products were being used. I asked about the latest observations and whether they were being used for spraying. When you think about the weather, and especially the radars, this is something that is one of the most important things because of the potential impact of wasting sprays because you didn't know that the weather was going to turn, or etc., or just to apply it well. And those are a lot of indicators which are available on the websites. But in fact, farmers use only 7 of them. So they are overloaded, well, all of them. So they are overloaded with information, and this could be displayed better, perhaps with an app, like a dashboard app, that only shows those 7, and then you can click somewhere else if you want to look at dew point. And actually, I think that DeepEarth is working on an app like this. So knowing this kind of thing can improve the way we deliver information, essentially. All right, so this was the main part of the study. So once you identified how farmers access information, well, the end game here is to find out how does that information impact their practices. So I'm going to go through this slowly because there's quite a few things. As I mentioned, there's different types of weather and forecast information. So in purple, we've got the real-time, the monitoring. So that would be the instant loops that you would see. That blue one is forecast overall, so just like the forecast, does it matter? And in blue here are the different horizons, so hourly, daily, weekly forecast. And in green are the outlooks, which are 3 months ahead at least. So this is what matters for their decision. And here, with those little symbols, is what they think would be really important to have to impact their decisions. So for planning, in general, at the farm level, well, all the forecasts are important, and they're all very used, as in like they're crucial for the decisions that they are making. So that kind of makes sense. Except, oh sorry, I just forgot that. So for planning decision, all the information is important, except the long-term, well, all the information is important and is being relied upon, except the very long-term horizon. So that would be great if farmers could know 3 months in advance what the weather would be, but they don't rely on it because it's not good enough. For spraying and ship management, it's such a different story. The short-term forecasts are what matters the most. And for spraying, it kind of makes sense. You need to know how the conditions are going to be in the next few hours, or right now even. And for ships, since it's an Also an outdoor activity, well, you need to know, well, actually, that's specifically when they are most vulnerable at shearing. You need to know if you have to push them in the bush to protect them or go into the shed so that you're not going to have any losses. And in this case, so those are the horizons that matter the most, and they are being relied a lot upon. For harvest, it's the opposite story. What matters the most is to know the weather 2 or 3 weeks ahead. And that was actually interesting because the assumption is that farmers will reallocate their resources, as in their labor force or their machinery capacity, to depending on what the weather is. So that, for instance, if the weather's coming, well, you may harvest another paddock or the crop that is most vulnerable, or etc. But in fact, to make those decisions, those reallocation decisions, farmers have to know more time ahead. Because very often they're constrained by the type of crop, so the most vulnerable has to get out first, and simply what time it was seeded, number of consideration. And they simply can't rely on the weather forecast for that. The only reason actually why it's like minor importance of the monitoring information here, that's because for security issues. So like when there are thunderstorms coming, they need to shut down the machinery. For seeding and fertilizing decisions, it's a more complicated story. In fact, it looks pretty average. So the longer horizons are what matters the most, not the short term. Also, for incorporation of nitrogen, sometimes it's good to know where it rained, but generally speaking, it's a long-term decision. But it looks like it's kind of minor importance, the weather, which is a bit counterintuitive. And in fact, this is hiding variation in the population. And I'll go through that. For planning, this is a distribution of the answers. So doesn't matter, matters a lot. Everybody agreed that, they all look at the weather for general planning. For seeding and fertilizing, the answers varied. Some farmers were, well, I need the information and I rely on it. And others were like, nope, doesn't matter. So the average is actually not an average. It's a fake average, if you want. Which is why it's important not only rely on the average, but on the distribution in the population. So let's go into a bit more detail in that, regarding that population heterogeneity for seeding. So for seeding, when we're talking seeding and weather, actually what we're talking about really is the timing of seeding. This is what matters. In those highly variable environments, what matters is how much moisture you've got in the ground. And the population is broadly divided in 3 categories. When we look at the importance, the relative importance of past rainfall, so how much rain did I have, and forecasted rainfall, how much rain may I have. And the important thing to look at, so 3 profiles depending on that. Here we have the trigger-based people. They wait for the rain to have sufficient rainfall for correct or sufficient germination. So they just wait for a few mils. Then you've got people who, they wait a bit, but not too much. So they pay attention to the forecast and they play it out. And finally, you have a third population, the largest. They don't care. They don't even, doesn't matter how much rain they got the previous year. It doesn't matter what the predictions are, what the forecast is they just plant on a predefined date. For the study, the important result here is that 2/3 of the population of farmers who don't care about the forecast for seeding. That is counterintuitive. We would think that the weather and the forecast and the rainfall is important for everybody, especially seeding. It's like one of the most important decisions in the cropping program. The thing is, at least for those people, they have much larger areas cropped than the other farmers, and the labor and machinery constraints, so ratio of how much seeding they can do per person and per machinery unit, are much higher. Yes?
Any regional variation? High rainfall zones, low rainfall?
So with 3 regions, I didn't see anything, but really I don't think I could. We would need to have more data across more environments, really.
Surely these are people who are dry seeding, right?
That's right.
Seeding before the rain.
That's right. Well, technically, actually, they are early seeding, so it may be dry most of the time, but sometimes it may be wet. But the point is a date, so they early seed. So I think the story, actually, to answer you, is a bit more complex. Of course, it's linked to the geography. So for example, in Myrtille, where you have a lot more mixed farmers, it's much hillier. So it's as much the topography as a regime of rainfalls. It's a soil combined. It's really a farming system thing. Yeah. For fertilizing decisions, I couldn't find the same as strong a pattern because I would have to essentially like go back again and be more precise now that I know those things. But it's a similar pattern. Essentially, there are logistics imperatives that override what farmers could be doing in terms of adjustment. We all think that farmers are adjusting their fertilizer depending on the rainfall. Well, they do, for nitrogen in particular. You have a little bit of margin for the in-season applications, but actually you don't have that much. 20% is like a very, very rough estimate. Otherwise, most of the decisions have to be made at seeding, and you have to purchase your fertilizer a year ahead. So really your margin of freedom is not that high. All right, conclusion of this bit here. The impact of weather and forecast information may very well vary within the population. So if you make assumptions thinking that everybody's got the same reaction, that's probably going to be quite erroneous. And it's not necessarily according to the assumed pattern. So, larger farms, more technologically equipped, the top farmers, well, all the other ones also use a lot of that information. So if you limit your economic analysis to those top farmers, like it's been done in the past, then you're actually forgetting a lot of the actual impacts. And there may be other factors, such as the program size versus machinery capacity or the cost of input that may be overriding the potential impact. I will talk about that a bit later. Then the scope of the additional impact may vary. So for the radar, everybody was thinking, oh, well, now they have a radar, fantastic. Well, actually, they were already looking at the radar, the other radars on the peripheries. That was kind of giving them an indications. And, for instance, for spraying, everybody assumes that there will be a lot of herbicide, in particular, being saved because people will be able to apply in a more precise fashion. In fact, herbicides and pesticides in general are so expensive that farmers were already very, very, very careful with it. And if something unexpected was happening, well, they would just drive to the other paddock, which is, a few kilometers away, where the conditions would be different. So that's actually very much, does not corroborate the previous assumptions. And for fertilizing, same, the room for adjustment is actually relatively low to start with. So this is important because we're talking about broadacre farming. So whatever assumptions you make at the individual farm level is going, of course, to be extremely scalable at the scale of the wheat belts. To summarize all of that, the impact of information may be smaller than what is anticipated because they already have been realized. We are in an environment that benefits from most of the best services in the world. Really, we already are very equipped. And other factors may override what you may think is important. It is not to say that the weather is not important. It's about putting a nuance on the scope of things. And lastly, I decided to add a bit of what do you think? Instead of asking people, what do you do? I asked them also, what do you think? And so what do you think about how the Bureau performed? Because some of those results, they were a bit like, it's not exactly the over-enthusiastic response that you would expect, or the impact of the radar in particular. It was a bit neutral. So what do you think about the Bureau? I wanted to see if there was a bit of a underlying current of anti-weather information or something, because we all know the general idea about climate change, for instance, in the wheat belts. Well, actually, the farmers are very, very happy with the Bureau of Meteorology. Most of them are very happy, but don't say anything. And what you hear are the 5% grumpy farmers who tend to be very loud. So then again, we have a perception of the farmers that may be quite erroneous. And I think that that helps put a bit of credibility on the results. They are not negative per se. Actually, they're quite fair. And when you talk to the farmers face to face, that's what you tend to have. You always have someone grumpy or someone over-enthusiastic, but those are the end of the bell curve. Another final question I asked just to be sure. So, as a farmer, now that you have the radars, what do you think is next? And they couldn't really answer. They were like, oh, well, we got the radars now. That's great. I don't really know. Just make it better. Improve the forecast. But at the same time, they know, and I was really surprised by that, most farmers are very aware how difficult it is to improve long-term forecast. So they're hoping, but they're not like bashing the bureau for like not going quicker anyway. So that's another really good success. Like something that could appear a little bit negative is actually not. This is a real positive outcome, is that the radars were missing. And now that they're here, well, right now, they can't really think of anything except perhaps a bit more performance, or let's put a few moisture probes in the ground, or more stations, but it's pretty good. So all of this is in a newly released report that I just come out. And of course, there will be a paper or two coming later. And I think it's important because it's really, I looked hard. And this is the first measured evidence from a process that you can repeat to inform modeling and future investment and evaluate the impacts of investments. So let me know if you want a copy or ask Marit. Briefly, to give you an example, because it's actually the next phase of the project, how you can use that information further to assess the radar benefits. If you think about the radars, so they collect information about the rainfall and the winds, and they will feed, well, actually there are three types of benefits from the radars. There's the impact of all the related activities, so the outreach, the communication, making people aware of the radar and then of other services. So that should start soon after the radars are in, but I really couldn't see any evidence of that. Any evidence that because the radars were here, for instance, someone else was using more products, or nobody was telling me, oh yes, since the radars come here and I've heard the communication from the BOM and DPIRD, now I know about all those things. There was absolutely no evidence of that, but then again, could ask better. The second type of potential benefits are improving the forecasts. So the radars are going to collect more information of better quality to feed into the models. So that is not going to happen right now, it's going to happen over time. So if you do a 20-year cost-benefits analysis, the benefit won't be very much then, but it will start to happen in a few years' time. So what is the impact of those forecasts, of those improved forecasts? That is something that the entire related scientific community wonders about. They looked at the potential impact of improved forecast and improved outlook. There is so much literature about modeling the potential impact of those improved forecasts. And they're all based on assumptions with regard to farmers' actual practices. The third types of impacts is the monitoring abilities that the radar loops gives. So that happens almost right away after the radar is installed. There's a little bit of maybe a year for adjustments, but it happens straight away. All right, so first type of outreach, well, I already answered that. I didn't see anything of that. So impact of that, almost nil. Radar benefits of improved medium to long-term forecasts. Well, from what I showed before, yes, potentially there will be a very large impact of this, because if the long-term forecast improve for seeding, fertilizing, and especially harvest, well, here there's still like 20% of the population for whom that would really matter. And potentially the others could start changing their practices because now they could actually rely on that forecast. But it won't be everybody. Fertilizing, same, we talked about the margin of improvement, not great, but that's 20% here. But for harvest, it could potentially be quite important. This is dependent on, of course, how much improvement in the forecast is expected from having more data from the radars. And you can calculate that, do a regression curve on the improvement, historical improvement of the... Yeah. Then we have the third type of radar benefits, which is the improved real-time monitoring. So there, before there was nothing. Well, actually, no, there wasn't nothing because the farmers were still already looking at the radars on the coasts. And for some practices, the impact is negligible. So I mentioned for harvest, there are some security benefits. But otherwise, in terms of how it impacts decisions with the economic improvements in terms of performance, that's relatively limited. A little bit in spraying, but the data shows that actually not that much. I mentioned how expensive the fertilizer is. For sheep, it was already pretty much relied upon. So, maybe there will be benefits, but not as large as what was expected, because it was already pretty good, or it wasn't relevant to start with, like seeding. However, and I didn't touch on that enough when I talked before, the non-financial benefits are really the most important thing here, I think. Because even though everybody said, oh, well, it's not going to change things that much, or a little bit, everybody was just simply so glad the radars were there. They were so happy about it. And I tried to see if that was because they were going to save time. And actually, that's quite rare. Only on maybe like 2 very large farms, the manager would say, well, it saves me from driving to the other farm over there. So, my time costs that much, so I will save that much money by having the radar. But that was really rare. I actually asked people, will you save time by reorganizing your activities? And said, no, because I have to do those activities anyway, and it won't make that much difference. But however, it will make my life much easier. So in the sense that they can wake up in the morning without having stressed all night about changes in whether they have to change their plans. Or if they change their plan, whether they can do it in essentially it's the human benefits, the convenience. And I'm sure that there are people here who can assess that. And actually there will be. Thais is taking up the job of quantifying those benefits, financial and non-financial, based on the baseline here. All right, any question? Thank you.